Hello all, welcome. My name is Vijay. In this session, we'll talk about materialized views in Snowflake. We'll try to learn below bullet points that I mentioned here. We'll learn the definition and the benefits of creation of the materialized view, the costs that are involved during the creation of materialized view, and as well as to maintain it going forward, and also how the data refresh to the materialized view we will see, and also we will see the different scenarios when we can go for the materialized view and benefits of it, and limitations as well, because in Snowflake still evolving around materialized views, there are so many limitations when you are creating it. We'll talk about them as well, and also I'll try to show you the different commands that helps to give the more information about the material views that has been created and when the last refresh happened, and where you can see the status, how much cost it took for the each refresh. Those kind of details also will go through it, and I'm going to concentrate more on use case based approach for this video, where I'll show you how to create, where to see, what are all the changes that happens when there is a change to the base table, when it alter, when it add new column. We'll talk about that. Let's see few other details as well for the materialized views. Materialized view is nothing but a computed data set derived from a query. Basically, we'll create a materialized view to improve the performance. Let me give a small example to understand and visualize a scenario where in general we'll create a materialized view. For example, I have a query against a table where there are limited number of columns, but it's a very big table, huge data is available in it. But in my query, along with the columns that are available in the table, I am also deriving few other columns based on the columns that are available in the table physically, right? So in that scenario, the query is taking a lot of time because I need to do many derived columns. At the same time, it has huge data, and also this is a kind of a reference table where the data is not frequently changing. Maybe the data load is happening maybe bi-weekly, or uh, after a couple of days once, something like that. And the query that I was talking about is frequently using in many other reports for analysis purpose, and many decision making processes. In this scenario, we can go for the materialized view. So what will happen is, the first time when we create the materialized view, it will do all the derivations for the columns, and then it stores the result set into the database. And going forward, whenever the same query is executing from different processes, it will directly get that data from the result set. As I mentioned, since the data is not changing frequently, there won't be any change into this result set until the next load will happen. Okay. So in this process, if you observe, initially we need to do the compute to derive the fields, as well as final data set that we achieved needs to be stored in the database. So there will be cost involved. So materialized view creation requires additional cost. At the same time, when the base table changes, that data needs to refresh into materialized view also, because materialized view stores its result set separately, right? So to maintain the materialized view also requires additional costs. But considering the advantages of the performance, as well as the query, since that is using many times in our processes, there we will save the cost, compute cost, because every time you need not to recalculate the derived fields. um, so um, it will be definitely helpful to go for the materialized view. Okay. Hope this gives a clear idea when we can create. I have given the details as well here. You may go through it and try to understand the points that I have mentioned here. And as I explained earlier in this use case scenario, so there are so many advantages. I have mentioned those advantages here. And I already discussed in the use case scenario. One point that I wanted to mention here is that the data refresh from the base table to the materialized view, it will be taken care by the Snowflake itself. We need not worry about. In the legacy systems, we may need to write some triggers or the procedure and schedule it to refresh the data periodically. But here, Snowflake itself will take care of it. And also, we have um, some limitations in the creation of the materialized view in the Snowflake. I have mentioned here the limitations. There are many limitations actually in Snowflake. One main important thing is you can create a materialized view only on single table. You cannot join the table with others, and you cannot use the user defined functions in the query definition. And there are so many other details, like you cannot use the window functions, and when you are using group by, all the columns should be part of the select statement, like that. There are many limitations. When we try to do the real-time examples in this session, I'll walk you through all.
Let's see how to create a materialized view. I have logged into my trial account, and there are no database objects has been created in this account yet. Uh, so now I'm going to create a table customer from the shared database object customer. I'm taking the first 1,000 records into this table. Let's create the table first. So now we have 1,000 records in it. You can see the count here, 1,000. And now I'm going to create a materialized view on top of the table that just created. I'm directly going and creating exactly the same structure in general in the real time. You might have the derived fields also, as I explained earlier. So in the materialized view definition, I have given the where class to select the first 2,000 records, but however in the base table we have 1,000 only. So as of now, it will consist only those records. In future, if we add more, then the materialized view also will have that data. So here I'm creating a secured materialized view. There are two types of materialized views are available: standard and a secure. Secure is more secure compared to the standard in terms of hiding the definition of the materialized view to the others to whom you will give the grants. So I have created, and now you can see 1,000 records are available, and see the metadata for the materialized view here. And you can see the name of the materialized view when it created, and database information and the number of rows available, and also the base table information is there here. And when it refreshed, and invalid is a false, that means it is a valid state now. And you can see the behind by column, which will tell you whether it is in sync with the base table or not. Since it is a 0, that means both are in sync. There is no data gap between the base table and here, since we just created. You can see that, and you also can see the definition of the view under the text column. Okay, automatic cluster is off. So this is how the metadata you can see. Let me query the views, and in the under the view also you can see the materialized view, but the number of columns will be limited in this uh, data dictionary view. Okay, so when you query the tables, so you may not see that you are only seeing the customer table that we have created. Now let's insert a few more records into the base table customer. I'm again selecting from the shared database table and inserting it uh, from the 1000 to 1500 records. So 500 more records I'm inserting here. So now in the base table we have 1500. When you query the materialized view, immediately you can see that there also 1500 records are there. But however, when you go and query the metadata associated to the materialized view, let's see what differences you can see here. So first and foremost thing, here it is still showing the number of rows is 1000. So what that means is the data is really not refreshed to the materialized view yet, and also behind by column is saying 3 minutes 24 seconds. So that means the last it is the material is not up to date, so the last refresh happened during the materialized view creation 3 minutes before. Okay, so these 500 records that we have inserted into the base table is yet to be refreshed into the materialized view. Okay, but however when you query the materialized view it is showing the 1500. So as I explained earlier, in this kind of scenarios what Snowflake will do is it will select the first 1000 records from the materialized view, and next 500 records it will directly select from the table. For us, ultimately, it will always give the latest and greatest data only. Now, let's insert 500 more records into the table. So, again, see here you have 2000 records now total, and when you query immediately, you can see that 200 records it is showing even from the materialized view. Again, the same scenario as explained earlier. First 1000 it will select from the materialized view. Next 1000 it will directly select from the base table. Still, it is now the materialized view is out of date. Um, so it has to refresh. This refresh can happen behind the scenes. We don't have any control on when it will happen, but however the data always it will show you the latest and greatest only. The refresh information you can see under the materialized view, refresh history, data dictionary view, uh, by giving the table name as a materialized view name. In that, if you see that there is no refresh happened at on the materialized view. I have waited for some time to give ample amount of time to Snowflake to refresh the data. So now let's query and see the red data is already refreshed to materialized view. So now you can see the 2000 records in the materialized view. So when I query for our materialized view, you can see that there are two times the refresh happened. You remember we have inserted data to the base table two times, 500 records each time. So that's the reason that it happened two times refresh. Um, and this is the credits used to refresh the data to the materialized view. Okay, so the same information we can also get from the table function from the information schema. This is from account usage, and this is from information schema, where you can pass the materialized view name as an input argument. and then getting the history, refresh history from here. Okay, so by default, it will it will take three arguments, the table function. So if you want pass anything as an argument, it will give the last 12 hours refresh history for all the materialized views that has been refreshed. And you can also pass uh, date range start argument, date range and end argument, and materialized view name. These are the three arguments that this table function will take. I'm trying to query last 7 hours that materialized view refresh history for this one. So I just want to show the various ways how you can see the refresh history for a materialized view here. And now I'm going to alter the base table. So I'm talking about this table. So in address, actually it is currently 40 characters. So I'm now increasing to 55 characters. By executing this, I wanted to see how our materialized view, which has created based on this table. Um, okay, so I altered the main table. So now let's execute it and check. Okay, so when you alter the base table for the materialized view, if you see, you can see that invalid is a true and invalid reason has been given here. Okay, so the DDL statement was executed on the base table, so that's why this material become invalid. Refresh the materialized view again to make it to make it valid. So I'm executing it. So now if you check, invalid reason becomes null, invalid is false. That means it becomes again active. So now what I'm gonna do is I'm going to add new column. So earlier I modified the existing column. Now I'm adding new column to it and see how the material view behaves. So when I add the new column to the base table, and now if you query, okay, so there is no change here. So what that means is if you alter the existing columns in the base table, then only the materialized view becomes invalid. But if you're adding the new additional columns, uh, it won't impact anything to the materialized view. You see the description of the table first. So now you have a C email as a new column, but when you describe the materialized view, so you may not see the C email here because that's additional column added to the table. So that's the difference between the views and materialized views. When you add a new column to the base table, automatically it will not refresh here, though the definition of the materialized view is select start from. Trying to create a materialized view on top of the shared table. Okay, so whether that is possible or not, I'm checking. So earlier, if you remember, first I created a table on the shared table, and on top of that I created materialized view. Now I'm attempting to create a materialized view directly on the shared table. So if I try to do that, it will create, there is no issue to create a materialized view on the shared data. Okay, in here I'm attempting to create a materialized view on top of the view. It is not allowing us to create a materialized view on top of a view. And so let's see if can I create a materialized view on top of materialized view. You know that we have this materialized view. I'm trying to create materialized view on top of it. So that is also not possible. You cannot reference the materialized view uh, in the materialized view definition as well. Okay, so now I'm trying to do the union condition, but on the same table, and I'm trying to create a materialized view here. Let's see whether it is possible or not. So we can create like this. Multiple select statements, doing the union can be possible. You know that with by joining the table we cannot create, but by using the union it can be created. Attempt creating a materialized view. So for that, what I'm doing is I'm creating another table similar like this, and then I'm trying to create a materialized view on different tables by using the union, and then let's see whether it is possible or not. So that is not possible always. Let me try to join two tables and create a materialized view. Whether it is possible or not, we'll check. So that is also not possible. More than one table reference is not possible in the materialized view. Okay. And finally, even if it is a self join also, that is not possible. Just wanted to show that. And you can suspend the materialized view for time being by executing this command. And after suspending the materialized view, if you try to query that, then it will say that materialized view is invalid. Okay, and then you can resume it if you want to again after some time, and then when you query you can see the data now back. Okay, so that is also can be done. So what else? So can we clone the materialized view? So I'm trying to clone here. So it is not possible. You cannot clone the materialized view directly. And you know, can we do the time travel? No, not possible. Time travel also not possible. I wanted to mention one point here when it comes to the cloning. You cannot clone the materialized view directly, but if there is a schema or the database where the materialized view is available, and if you are attempting to clone the schema, entire schema, or attempting to clone the entire database, then this materialized view also will be cloned. Okay, so that is possible, but directly the materialized view cloning is not possible. And of course, we cannot do any DML operations on the materialized view, including truncation of the materialized view. That's all about materialized view. Thank you so much.